Hi, I'm Gene Shuey, and welcome to In the Classroom. We have a very interesting subject for you today. It is the art and the science of selecting compensators and how they work. Now, the compensator minimizes three things of a 1911 or any handgun. And handguns are what we're going to talk about today, and they're compensators. All right. Here's a 1911, and when you shoot it, you will have recoil, that's number one. The second one is muzzle rise, that's number two. Number three is the torque of the bullet when it leaves the barrel, and that's going this way. Now, this is what these compensators are designed to do. Let's take a look at some of the compensators that are on the market today. Then we'll get into the engineering and the science behind it and how we retard these three things on recoil, muzzle rise, and torque, okay? This particular compensator is a little bit, I would say, not commonly used today. It has all of these holes, and what it does, it directs the gas out in different directions. What this basically does is just keep the muzzle down. Others compensators have different features. This one in particular is designed for a bull barrel and it's threaded on. Next, we have one that's the same size as the other one that we just seen. Now, this one is also for a bull barrel, but look, we have chambers in here, and each one is of a different size. Now, I'm going to explain something. The gas comes in this way, and it comes back out through the top. That's pushing the muzzle and the gun down. But also, if you can see, you will see a baffle here in this chamber. That baffle is when that gas hits it, it's just like the wind hitting your door and blowing it shut. It pushes the gun forward. Now, that has a tendency to reduce the recoil. So that's one and two. We have more gas coming out here. Therefore, it's not going to be quite as efficient if these two chambers were of this same size. So we make them smaller and smaller. So that has a tendency to increase the velocity in the force down. All right, let's check these out. This is the one that came out, oh my gosh, I believe about 35 years ago. This was one of the first compensators, and it does not go on the barrel at all. It goes on the slide. As you can see right here, where you have the lugs and just turn it right on. That way you can use any existing barrel that's in your frame, okay? All right, but this thing has drawbacks. How well does it work? All right, if you look in here, there are no baffles. So it's not going to do much for the push back. Okay, the push down, this gas is going to come out with the bullet right here. And what that does, my gosh, look at that space. So the gas is going to come around the bullet and everything else. So that's going to affect the accuracy a little bit. So the effectivity of this is very little. And I would not, if you want a compensator, I would not buy this at all. But they are cheap in things of this nature, and I don't think you're going to get that much out of it. All right, let's go into a little bit more advanced one. This one, you use a standard diameter barrel, but it is threaded. Okay, now you don't use a bushing. This is fitted to the interior diameter of your slide, which is good. We have two different weights, if you will, in a barrel or actions, and also the gun. You have a dynamic weight, which moves. Then you have a static weight, which does not move. Okay, the barrel in the comp is a static weight. It doesn't move. The dynamic weight is your slide. So there's design characteristics that you can go along with your comp and your barrel. If you're using a high magnum and so forth, then you may want to use a bull barrel. If you want to keep the gun a little bit lighter in the muzzle, then you use a standard one with this cone. Okay, let's get into this comp and how it works. This is a little bit different, and it's kind of good. We have our holes drilled here at an angle. So that's going to make the gas go this way and this way, which is good. That's going to take care of number 3 to a good degree, but it also is going to push the gun down. We also have a baffles in here, as you can see here, here, and here, all right? That's going to take care of some of the rearward thrust of the gun. That's the recoil. Now, just take a look at this. These small holes, okay, that's where our maximum pressure is going to be. That's going to push it down and keep it from torquing. This chamber is small, and that's going to have some force. It's going to have a baffle and takes care of recoil, takes care of muzzle rise. But we have a big opening here, and it's slanted. Originally, this is an earlier design of good compensation, is that they wanted the gas to hit and go out like that to keep it from coming back into the scope on your pistol. Is it a good design? Well, relatively so, but you're going to get your maximum blast on your scope from this one and this one. This is not necessarily the best of designs to finish up with, because the gas that you have is going to be fairly well depleted when it gets to this big chamber. This is where you want to close the chamber down till you get maximum amount of the pressure that it comes to that chamber to give you the thrust. Okay? Now, we have talked about something in compensators. The hole here, okay? This is very important. And this is something that was realized, fairly about halfway through designing compensators. Your bullet diameter has got to be very close to the hole that goes through here, okay? And it's only 10 thousandths. That is the optimum. If it goes less, you have a chance of maybe inferior alignment of your other chambers. I'll talk about that in a minute, okay? Over here, if it is too big, it's going to get back to the one that we had over here, where you're going to get influence of the gas as the bullet is going out through the chambers. So that's very important. All right, the other thing is this. How are you going to get all of this precision and everything lined up with your barrel? Because the bullet's coming out of that barrel straight and true. So what if this is a little off? These are drilled, you will say, on a CNC, and the threads back here, or however you fasten it, is not in true alignment. It is simple. Most of your compensators, for the high-end gunsmiths, we buy the best compensator. If not, we can make one. But what we do, we drill the hole here, and it's undersized, okay? Just slightly, okay? Then, after it's all assembled, everything is put on the barrel, then we take a chambering reamer, and it has a long guide in it, and it goes through here and into the barrel, okay? And then we hand ream that so it is in perfect concentricity. This is extremely important. You just don't buy them and put them on. If you do, there may be that possibility that your bullet will hit one of the chambers. And if you're using a plated bullet, that can be very bad because the plating on those is very thin. And what you will do is to get a cut on it, and as it goes out toward your target, that plating will peel back and you'll start to keyhole. So remember that. Now, this is one of the most modern of our comps, and I will explain this for you. Okay, again, this is for a standard barrel that is threaded. This is what we call a cone comp. We have everything that we've talked about, and it takes care of problem 1, problem 2, and problem 3. Look at our chamber. This is a little bit difficult to see, but this one is bigger, this is a little bit smaller, this is a little bit smaller yet. Good, because our maximum thrust is going to be here, and then it's going to taper down, but our chamber is smaller, therefore we're getting very close to this amount of force. And we do this all the way down into our third chamber. Okay? Look on the side. Aha! You haven't seen this before. Now, we still have baffles in here. Now, that's going to direct the gas not up, but out on each side, is to make sure that we have even amount of force, and that's going to take care of the torque. But all right, let's say we only have it on one side. That means the gas, as it comes down here, it's going to hit here, and then it wants to get out over on this side. That is going to take the bullet and cock it, maybe just a micro of a thousandths. But that's going to give it a little bit of a wobble. We don't want that. Accuracy will go out the drain, right down the drain. This is a good comp. These are some that we use in competition. Now, we're going to stop right there. We have seen all of the add-on comps. In other words, they're threaded onto the barrel. Let me show you something else. This is really unique. Let's take this one right here. This is everything that we talked about. We got baffles here, we got baffles there, holes, we're directing gas, everything. But what about this? This is unique. This was designed by Will Schuman. He was an aerospace engineer, and he was into propulsion and stuff. And he came up with the idea, let's trickle down the force. And now also, let's increase the amount of force that it does, okay? And these are called Venturi holes. They are not just drilled down into it, okay? They start at a smaller diameter, and then they come up like a cone. So if you have an opportunity, if you can see down in here, that hole is a bit of a different size. So now, here's what's happening. Here's the principle behind this. And this is what I use in competition. And I'll show you that in a second on my gun. Okay? Right now we're getting close to a maximum amount of pressure. We're bleeding it off here, but being it has the Venturi, we're increasing the velocity that it comes out. And as it comes out at a fast rate, then the chamber opens up here, the hole, like a cone. Now that is escaping, but we've got pressure, pressure, pressure. And as we come out here, if you notice, all of these were smaller in size. So that took care of some of our pressure loss back here. If we did not have the smaller chambers and they were larger, it would be less effective. So it's well designed and well engineered. We also have this to take care of the torque on the gun. This is pretty good. Okay, over here, same thing. We can select, okay, now I don't know what caliber you are going to be using a comp on, but let's put this into perspective. This would be good for a 9mm because you have less pressure, less capacity for powder and stuff. Okay, we get into a 40 S&W here. We've got more powder, more pressure. It's going to burn longer, so we add the fourth hole. And in a 45, this would also be good because we have less pressure. This is kind of unique. Our full-length guide rod will go through this hole, as you can see. All right. Secondly, this has everything that we had talked about. Okay, we've got our chamber, and they get progressively a little bit smaller, but not much. This is not as modern as the ones that I have showed you. This is how it is mounted onto the barrel. That's the reason why I brought it out. You take a standard barrel that is threaded, and the comp is threaded on the cone. You screw it in, put your Loctite on it, and then you have to trim, being that you have a rise here when it locks up. You're going to have to cut the end of your slide for that 1 degree. You may not do that, but your gunsmith will. But I'm just showing you some of the operations that goes into putting a comp and a barrel in. Now, way back when I was shooting, you've heard of Bartow, okay? The man that started this was Irv Stone II. Now, he has passed away, unfortunately, and his son has taken over, and his name is Irv Stone III, okay? Back in the 60s, late 60s and early 70s, he came to me and said, I want you to try this barrel. Maybe it will do something for the muzzle rise and the recoil. What he did, this is for a 5-inch slide, okay, and he made this a bit of an inch longer, and he cut slots in that, thinking the gas, when it bleeds out and so forth, would have enough thrust to bring the barrel and the gun down. I tried it, and it was basically negligible for me because I was strong at that time and I could hold the gun. I couldn't really feel it. But what I did like was the extra 1 inch out there, and that did help a little bit. But far as the compensator, no, I wouldn't waste my time on it. But it is a good barrel. We've looked at, I would say for 1911. Now we have one for a Glock. Okay, let me show you one that is on a Glock, right here. This is probably the best that I have seen for a Glock. One, you get a barrel that is a little bit longer and threaded, okay? It just turns and it comes off, okay? Let's take a look at it. We have 2 equal holes. Don't forget now, this is a Glock 17. It's a 9mm. So we don't need all of the other baffles and a lot of extra holes. So we have the 2 here, but it has a good baffle on each one. That takes care of 1 and 2. We have our discharge port here, which takes care of number 3, and that's the torque. Now, here's something that we haven't talked about, but I saved it for this portion here. And that is, now that we have less recoil, we're bleeding the gas off, we have less of everything. Now, the recoil spring has less to do. So if you start with your standard recoil spring in here and use standard chamber pressure ammo and stuff, you may get a jam. And what happens is if you use, we'll say, Winchester white box in 9mm, and in this gun, you would probably have a jam, okay? Failure to feed reliably, we'll put it that way. So what you do is you go down to a 13-pound spring. This is quite common using a Glock and 9mm. Now, if you use government issue ammo like they use in the Marine Corps and stuff, that recoil spring that comes standard with your Glock works fine. Same way with the IPSC power factor. That also works fine. It's a good one, and by the way, this is my gun, so I have one on it, and it works great. Now, let's go back and take a look at another gun. Look at this. We've got 4 Venturi holes, and we also have that, what we call the big rib up here. That also adds weight. Don't forget, the barrel is static weight, so that helps keep the muzzle rise and the recoil at an influential minimum, if you will. Okay, I shoot high power loads in this. So I've got a big chamber, a medium chamber, small chamber. Come over here, and then I have these two, but I also have baffles in there. And I have to use, I would say a couple of tenths of grains more in my hand load, but it meets IPSC power factor, and I shoot a 124 grain bullet in here. And the velocity in this, which has been chronographed for all of the national matches and stuff, at 1,375 feet per second. And the recoil spring is a 7-pound, because I've been bleeding all of this stuff off, and there is virtually, under slow motion camera, no muzzle rise, no recoil, no flip, no nothing. And when I'm on a hot streak, I get 5 shots a second and still hit. This is what a compensator will do for you. Now, if you are going to carry a gun, then I would suggest a very small comp and so forth, because the gun that you will have will probably be small. Okay, now if you're using a standard 1911 and you want a comp, then I would probably go to a 2-chamber comp, and with the last chamber there, have it a hole in there for torque. The reason why, for a carry gun, you wouldn't want a big comp much like this. I would keep it to a minimum of half that size. And as we saw over here, we have 1 chamber and 1 chamber here. If this was on a 1911, on a 45, that's all you would really need. And it will give you an extra, quick second shot. However, there is a drawback. Now, remember the old time movies when Humphrey Bogart would have his jacket on and he had his little 380 in here, okay? And the bad guy would come up and he would put his hand in his pocket and then he would shoot right through his jacket. With a comp, you wouldn't want to do that, because it would be a real hot time for you. It really would. You would be dancing around, and that's not good. Anyway, you have seen a lot on compensation. Now, for you, we talked a little bit about caliber selection and what kind of a comp that it would be. I would suggest do a little study on it and so forth. Pick out the comp for you, and don't forget now, whatever comp that you get, make sure that it is of the right caliber and of the right design and is put on properly. That's going to be the key to it. If you don't have a machine shop, now this does not include the Glock, because it's very simple to do. And it's machine to precision, particularly when you use a KKM barrel. What we had here was KKM all the way on the Glock barrel and the Glock comp. And they come as a package if you want it. It's ideal. Anyway, now you can have some fun. Select it, and don't forget now that when you start shooting, you may have to change your recoil spring, because it's not your gun's fault that you have a little bit of failure to feed. Okay, I'm Shuey. Good luck to you. See you next time.